For this video, we're going to do goal 4 and 5. So for goal 4, they want us to use the impulse formula to calculate the change in momentum. And if you look at your choices, impulse formula is force times time. So I'm going to write that across the top. So impulse equals F times T, which is force times time. So use this impulse formula to calculate the change in momentum. So this is just going to be impulse is force times time. So the force in this case is 8 newtons. If it's applied for 2.5 seconds, I'm going to multiply 8 times 2.5. That turns out to be 20. So my impulse would be 20, and the units are going to be newtons for the force and seconds for the time. So they're just reported as newton seconds, newtons times seconds. What would happen to an impulse if the force is doubled and the time doubles too? So if the force doubles, so we're still working with the same equation. So this is the same idea as we've done before. We always compare it to if they are both 1. So 1 times 1. If the impulse force is 1, time is 1, then you get an impulse of 1. But they're asking us to change the variables. What if the force is doubled? So instead of 1, we're going to plug a 2 in. The time is doubled, so instead of a 1, we're also going to double it and put a 2. When we multiply those together, we get 4. So the answer will be, when the force and the time are doubled, then the impulse will be 4 times greater. You should get a 4 as an answer, and 4 is 4 times greater than 1. A point guard runs down the basketball court and runs into an opposing center with a force of 700 newtons for 0.9 seconds. What impulse did she experience? So same equation, impulse is force times time. The force is 700 newtons times 0.9 seconds. So we're just going to calculate 700 times 0.9. So the answer would be 630 newton seconds. The next question is all about the same equation, but we're going to maybe have to solve for force or one of the other variables. So what is impulse? Goal 5. An impulse is a change in momentum. That's the official definition. Change in momentum, which is equal to the product of force and time, because that's what the equation is having us multiply, force times time. So a little boy is playing with this toy truck, and he pushes the truck so it hits the wall with an impulse of 250 newton seconds. The time the truck is in contact with the wall is 0.2 seconds. What is the force? So we're working with the same equation, because they're giving us impulse this time, and we're asked to find the force. So they also give us the time. So I'm going to plug 250 in place of the impulse. My force is what I'm looking for. What is the force? And the time is 0.2. So I'm going to put a decimal right there. So 0.2 seconds. So how do I get rid of the 0.2? I divide both sides by 0.2 to solve for force. So 250 divided by 0.2 turns out to be, the force would be 1,250 newtons. If he puts a padded mat up on the wall now, he pushes the truck, hits the wall with the same impulse, because remember, impulse is change in momentum. So in both cases, the truck is moving and then it stops. So he's got the same impulse. So impulse is going to be 250, which is the same as the example above, but the time of contact with the wall has increased because the wall is padded. What's the force now? So we're trying to solve for force, but our time has changed to 1.5. So in both cases, we divide by 1.5. So 250 divided by 1.5 turns out to be a force of 166.7 if we round it, and that would be newtons. So you can compare the two. If you have the padded wall, oops, you can't see that, sorry guys. So the padded wall would be 1,250 if it hits the padded wall, But the impulse, when we divide by 1.5 seconds, ends up being 166. So the force on the car when it hits the padding is a lot less than when it hit the brick wall. All right, the next one. If you run at the same velocity, the impulse of hitting a brick wall is equal to your impulse from hitting a padded wall. That's because you come to a stop in both cases. But the force you feel when you hit the padded wall is less than the brick wall. Explain, using the physics of impulses, why you feel less force when you run into the padded wall. Okay, so here's the idea. If you have the brick wall and you have the padded wall, in both cases, they say your impulse is the same because you are coming to a stop. You're changing your momentum from moving to stopping, so your momentum is the same. Let's just say it turns out to be 100. Okay, in both cases, the impulse is 100. I'm just making this up. All right, when you hit, the force you feel when you hit the padded wall is less. So let's just make the force 2. Okay, what would the time have to be? And this is totally exaggerated, but it would have to be 50 seconds, right? But what if you hit a brick wall? You're going to feel a much bigger force. Let's say you feel a force of 50. How long does it take to stop in that case? To get 100, it would have to be 2 seconds. So what we're looking at is the time factor. Okay? What happens as you increase your force, like we did here, you decrease the time it takes to stop. Okay? So basically, that's the answer. When you hit something that's padded, you feel less force because you had more time to stop. So basically, these guys are in an inverse relationship. All right? And that would be the answer.